30 of their ATSC3 deployments to date. So lots of choices for HDR, and HDR is an important feature for ATSC video. And then, as I mentioned before, we support high frame rate with a technique that's called temporal layering. And so this is the idea of, if you shot your video like sports video at 120 frames per second, you get much better motion. You know, if you're watching hockey, or I saw a clip at the NAB show, a vendor was showing some Tour de France bicycling, and at 120 frames per second with HDR, it was some of the best video I've ever seen. It's really, it's pretty spectacular to combine HDR and high frame rate. But ATSC allows devices that can't decode and display at 120 to still decode at 60 or 50 in the European standards without losing fidelity. So there's a way inside the bit stream to sort of mark the even and odd frames, basically, and have some less capable devices only take the evens, in a nutshell. And then the third optional feature that's useful, and I have a slide with a diagram on this, is spatial scalability. And so the idea of spatial scalability is to have two streams at different resolutions. So you could have a base stream that is mobile oriented with an enhancement stream that gets you up to 4K. And so these two streams can be used in parallel, and that can be coupled with the ATSC3 physical layer. So the ATSC3 physical layer, which I think you heard about previously, has these PLPs, and it has this LDM capability. The idea is there's differential service quality. So if you have, if you're in the desert and it's very flat and you have really good coverage, you don't need a lot of extra protection for the video and audio services. But if you're in the mountains, or you're in a more difficult transmission environment, you can give more service quality. Or if you're trying to serve mobile devices that are moving, you can give appropriate physical layer quality. So what you can do in ATSC3 is you can marry that physical layer capability with these video streams. So you can make a very robust base layer video that can be received by both mobile and fixed devices. And then you could have an enhancement layer that's probably only going to be receivable in a stationary environment, which has much less protection at the physical layer, but much more efficiency. So it doesn't cost you that many bits in terms of your 6 megahertz spectrum. Let me try to get a picture, because I got to just jump ahead a couple of slides to sort of show you a picture of this. Oh, there we go. So here's a diagram that sort of shows this. And sorry, it's a little bit of an eye chart, I suppose. But on the left, what you would have is you would have sort of let's say a 1080p HD video, which is downsampled to 540, and you'd have a base layer at 540 and an enhancement layer at 1080, and those are the blue boxes on the left. And then they would go into the ATSC3 lower layers, including these physical layer pipes, and you could differentially protect them. And so you would have those where the little lightning bolts are. There's a high loss channel and a low loss channel. And so for a mobile or distant receiver, you could get just the base layer, but for a fixed receiver, you could get both. Back up a little bit. Okay. So, so I mentioned at the beginning that VVC is the next generation video coding from MPEG. And so I might say, well, ATSC3 is done and it's stable and it's being deployed. Why would we want to put a new video codec in? And the real reason is because VVC has achieved 40% better compression performance than HEVC. So you could have, it's basically a 5 for 3. If you had 3 services in HEVC, you could get 5 of the same quality services, same resolution, same video quality with VVC. So it's the future. It's a pretty big jump. And HEVC was already a big jump, but this is going even farther. VVC could support 8K, which a lot of broadcasters think is a stretch, but we think that there are a number of capabilities in VVC that make it compelling for ATSC to put in the toolbox. So we are currently in my group developing a VVC-oriented ATSC standard so that we'll be able to introduce it. There are some new requirements, new things that people want to do that may require not just the video group to work, but some of the systems groups, things like portrait mode video and a bunch of other things that may require coordination inside ATSC, so that may take a little longer. But I think, VVC is a very important next step for ATSC, and it shows that, Madeline always says, the ATSC 3 system is going to evolve. It's going to always be state of the art. We are going to evergreen it with new technologies when those new technologies make sense for broadcasters. And we think that VVC is such a jump in terms of capacity and quality, and it actually opens the door to things like immersive video and things like AR and VR, which don't seem to be in broadcasters' mind today, but VVC is the basis of other things happening in MPEG in the immersive space. So I want to put this slide up with the big red. Your mileage may vary. People ask sometimes, how much better is HEVC or VVC compared to the older codecs? And so just to give you an idea of the history of MPEG codecs, back when we first started doing ATSC1, we used the MPEG-2 video codec, and that was standardized a long time ago now, 1996. And what you could do with MPEG-2, if you look today, the equivalent with VVC is, dramatically lower bit rate, right? What used to take, maybe 15, 16 megabits in an MPEG-2 service today could be done in 2.5 with VVC, right? So it's that many more channels in the same 6 megahertz spectrum, right? So each generation of MPEG codecs targets a 50% gain or a 2-to-1 versus the previous. VVC got a little bit less, but it's still a big jump. So just to sort of go, roughly 16 to 8 to 4 to 2.5, it's a pretty big jump, and that's why we're doing VVC, and that's why we're sticking with the MPEG codecs. So stop here. If there are any questions, happy to take them now, or if we're out of time, we'll move on. All right, thank you.
Good morning. I'm Sandy Kosach, and I am, my sort of title is chairman of Pearl TV, and we're a consortium of broadcasters in the United States, and they're the major media companies in America. And it also includes the 5 main networks, 6 main networks actually, both ABC, NBC, CBS, Fox, and then Univision and Telemundo. And so we cover about 98% of America as far as the coverage across all people. And Pearl has been around for about 11 or 12 years now. Initially, we worked on mobile broadcasting, but for the past 7 years, we've been working on 3.0. And we thought it made sense that broadcasters, if they work together, that was much better than working apart. And if many of you are aware of the competitive situation in America, broadcasters normally didn't work together. So this has been a wonderful journey that together we have worked on the standard, we have worked on public policy, we have worked on consumer research, business research, and we're doing it together to understand. At the same time, the individual members, which is about 13 major companies that are within Pearl, they can actually carry out their business priorities in the ways that they see fit. But basically, Pearl has worked to put together a toolbox and things that we all can work in common. And it's been very successful. Normally, the broadcasters didn't necessarily worked together, they competed. And so I actually think my title would actually not be chairman, but actually cat herder. Is the animal, is what, in Jamaica, would cats be the hardest thing to try to herd? Is possibly. And so, I've been very pleased that I thought, wow, this is going to be a major undertaking, trying to get everyone sort of headed in the same direction, but it's actually worked very, very well. And we sort of had, in some ways, we had the wind at our backs. We had a wonderful standard. The Atsc 3 standard is a big, big toolbox, as you've seen over the past day or two. And it's got all sorts of features that you can choose from to as you roll it out here in Jamaica, and just very, very happy with what ATSC has done to provide that. And as far as audio and video, the first thing that came to mind as we're going down this, we thought, video would definitely be probably number one in research. And Pearl undertook multiple consumer research projects. We went to the consumers. We had 4 or 5 different research projects, and we said, what's most important to you? We showed the greatest video that 3.0 could deliver. We showed or let them listen to the audio. We showed how features can change and how you can buy this TV set and you're actually good for the future, and you don't have to buy another TV set in the next few years. And the research came back. Audio and video were like this. We would show them beautiful scenes that 4K, 8K, high frame rate, everything that Alan and Skip talked about. And they said, we love that. And it was at about equal level. And, the pictures were gorgeous. And, the thing was that they, at the same time, could see some of this in stores because it was already some of these parts were being offered on TV sets, whether you used a DVD to watch it or you streamed it or whatever. But they could actually experience it. And so they sort of had an understanding. But then we also played them back audio. And we said, we can provide audio leveling where sometimes, some things appear to be louder than others. And they said, yes, we'd love that. And on all of these, both video and audio, consumer positivity, or that they considered it important in their next buy as far as a TV set, it was as high as 80 or 85%. You do not see those numbers in America as far as a new product that's coming out onto the market. 85% is unheard of, as far as we definitely want that. And we also asked them what they would pay for a TV set if we could offer all these things. So we took all that information in. The other thing that was interesting, a lot of times, I know I have it, it's hard for me to understand the actual dialogue that's on the TV set. And whether that's because the person's speaking or that there's ambient noise in the room. And we showed them a way to bring the dialogue up on the TV set. And they said, yes, we want that. And they said, well, actually, several people said, I'd buy it just for that. And so, when we have done this consumer research, we've done follow-up business research as far as consortium. That has, there is wind at our back. When you have that type of consumer demand, that type of consumer, this will make our viewing experience much better. It is much easier to then roll out a new standard. And where we stand in the United States is we're about 50% done. We're getting some major markets done this year. It will continue. We'll probably be at somewhere between 65 and 70% by the end of the year. And so that will basically, probably mid next year, we'll get all the major markets done. And that will get to about 70 to 75%. And then the smaller markets will take a little bit longer to do that. But of course, that is enough to keep things moving. But audio and video have been very, very much on the front and center. You'll hear some other things that I consider to be also important, like the emergency alerting, like that you're able to evolve this standard and you don't have to buy a new piece of equipment. There can be firmware updates and TV sets and all. Those are all things that the consumers say, yes, this is really going to make a difference for us. So I'll be glad to answer any questions as far as the sort of 7-year experience we've had so far. And if after I speak, if there's time at lunch or whatever, I'll be glad to talk to you individually. Any questions?
Would you be able to share the research findings?
Yes. And what I'll do, I'll send it through Madeline and all. But yeah, we have a summary, and there's been multiple ones, and we'll share that with you. Any other questions? Great. Yeah.
It keeps happening to me every time I come on stage. I gotta watch it next time. So, good morning, everybody. I think this next session is about advanced emergency messaging. And before I get into this, I want to talk a little bit about the fact that Jamaica is no stranger to natural disasters, whether it's hurricanes, storms, earthquakes, flooding, tropical cyclones. We've endured these. I think the earliest record of a hurricane was in 1722 on August 28th, when a hurricane killed roughly 400 people. There've been a number of major hurricanes after that. Hurricane Allen 1980, Hurricane Gilbert 1988, Ivan 2004, and there's numerous others. The idea that we could leverage this technology of ATSC 3.0 to somehow save lives, help people understand where to go after a hurricane, where if there are food shortages, to help first responders understand where to go if there's looting and crime, help people understand where roads have been blocked and bridges have been torn down, all important for our economy and our society and our people. And I think this is a great panel. I'm really happy to introduce to you Mr. Ed Zarnecki, who's the VP of Global Government Affairs for the Digital Alert System, as well as he's the Chairman and Executive Director for Next Gen Video Information Systems Alliance. Following from Mr. Zarnecki will be Niam Dang, who is the Senior Director of Emerging Technologies at One Media Inc., a member of the Sinclair group of companies. So please help me welcome Ed Zarnecki to the stage.
Thank you very much. Thank you. Really appreciate being here. I'm amazingly excited and honored. I'm especially honored and excited to not have tripped over the stage, which I do at every single presentation. I'm like a walking sitcom or shitcom, depending. You're not going to live that down. I'm sorry. So I'm not sure I can do that presentation now. I want to draw on a little background presentation. There's actually been a tremendous amount of work done in emergency information in this region, across the Caribbean. A tremendous amount of work in innovating with ATSC 3.0 and a whole range of emergency information solutions. So I'm going to ram at least 6 days worth of conversation into 15 minutes or less. So bear with me. I'm from New York, like Boston. I'm going to probably talk really fast. So slow me down, throw something up here, a dinner roll or breakfast roll to slow me down, but we're going to run through this. Not going to talk a whole lot about my company, but I'm with Digital Alert Systems. We provide EAS solutions, emergency alert system solutions, to the U.S., Canada, and the Caribbean, but also very heavily involved in and working with companies like Sinclair and Evoca and ARC Multimedia in the U.S. on implementation of advanced emergency information in ATSC 3.0. EAS systems have been deployed, and I'll define what EAS is, but EAS systems, emergency alert systems, that's redundant, have been deployed across the Caribbean. In that first bullet point, I won't list out the countries, but these were all deployed as part of the United Nations Development Program. Boy, I'm full of redundancy today. I'm not sure why certain islands have been left out of that program. I raised the question very early on. Key ones left out, as you might well reflect on here, but these allow the deploy. They put together a alerting backbone for those island nations, internet-based, which is a little concerning. We'll talk about that. And our part was to deploy the broadcast interface at primarily radio stations, but radio and TV stations in all of these islands. In addition, countries or areas like the BVI, Cayman, Trinidad, and Tobago have other parts of solutions, the Bahamas as well. Cable TV in Bahamas and Trinidad. In the Cayman Islands, the BVI, they put together an end-to-end broadcast alerting solution separate of the UNDP project because, of course, they were not included for whatever reason in the UN program. Also going to reflect a little bit on advanced emergency information, OTT deployments in the U.S. and what we're starting to work on right now with an AEA lab system in Canada. So a lot of real-world stuff. I'm not going to talk a lot about theory. I think Neem is not going to talk about theory. We're going to roll up our sleeves and talk about what's actually being built and reflect on how that might be able to apply to Jamaica. Okay, that's the map. And of course, there's a significant island in the center of that map that is not covered. But these are the alerting solutions that have been deployed so far across the Caribbean with a lab presence in Mexico as well. So how do broadcasters, particularly television stations, present emergency information? There are 3 typical ways. The TV newscast, the bulletin. There's an emergency, your news crew finds out about it, you get a tip, the government informs you, makes the call, please put this bulletin on the air. You do that well. The second type of solution that's really a government-run, government-controlled system is the emergency alert system, which is a very well-defined, and by that I mean very regimented system for placing alerts over the air. If you've been in the United States or these other islands, you probably heard the tones, which I won't mimic with my own voice, but you've heard the tones and the voice on the air or the banner across TV. It's highly intrusive, but very effective. It's bulletproof. It very rarely fails, but everybody gets the alert and it's in your face and really should be reserved for that most urgent situation. Our colleague mentioned hurricanes. You wouldn't necessarily use EAS for hurricanes because that's a long warning situation. You wouldn't have EAS crawls going off for the 3 days ahead of a hurricane. But if there was a coastal flood surge, a coastal storm surge, that would be an EAS event. So how do you tell people there's a hurricane coming? Well, the newscast, the weathercast, but a new service that ATSC brings called Advanced Emergency Information or Advanced Emergency Messaging. We've got about a dozen different names for this service. We need to standardize that. Advanced Emergency Information is an app-based urgent information messaging system. It targets a broader range of content more flexibly than EAS. It's less intrusive, and we'll show how. It provides greater targeting support. If you think about it, it's kind of a fusion between what you might have on a mobile app, Android or iPhone. Well, that sounds a lot like XTV right there. Between a mobile app and an urgent messaging system. So I'm going to talk a little about EAS, deep dive for 2 minutes. because I don't think we can understand where we're going with this unless we understand the past or what we've done in other countries, and frankly, some of the mistakes we've made in designing this system so narrowly. Again, EAS is usually a government-administered system. Official sources, FEMA in the United States, Canadian provinces, EMOs in the Caribbean, control the alerts. They determine what gets sent, and the broadcasters typically have limited control. In the U.S., there's a lot of discretion. The American broadcasters are voluntarily part of the emergency alert system. There's only 1 or 2 messages they must carry. But in Canada, they have something called a broadcast immediate flag. In the Caribbean, it's called a broadcast intrusive flag. And that's probably the best word for it, because then the broadcaster has absolutely no choice. The device is automatically put to air by EAS equipment. Message types are, however, pretty well defined. Tropical storm warnings, hurricane, I won't go through the list. Amber alerts, you have an Ananda alert here, very similar to an Amber alert in the US and Canada. Evacuate, shelter, law enforcement and civil emergency messaging, designed also to keep spam messages out of the system. You can't do a campaign ad over the EAS, or you shouldn't. Sheriff got in trouble for that once in the US. They actually ran a campaign ad over EAS. How are these alerts sent? Well, 2 ways. And again, if you're familiar with the US system, it began in the Cold War, long time ago, radio relay, where one station broadcasts to a series of stations and it trees out that way. It's a branch and tree system, also called a daisy chain. Tones over the air, FSK tones, FSK tones, followed by voice, followed by end of message. And for TV stations, those tones are modem tones. We can compose a sentence out of those for a very brief message over the air. That was supplemented about 10 years ago in the US and Canada by internet-based solution called using the Common Alerting Protocol, which is an XML-based format. In the US, it's primarily an internet distributed system, which means it fails a lot of the time. FEMA does not like to talk about this, but since they put all their eggs into the internet basket, if there's a storm, the internet is out. And we've seen this time and time again. Canada, interestingly, is an all internet system. And they don't have many statistics on failure rates, but Canada seems to be a kind of an edge case. In the Caribbean, the backbone is cable and wireless. The backbone is internet. And that presents major system vulnerabilities, and I'm not really going to get into that, but it's a big risk factor. So last thing I want to say about EAS is the system architecture. If you have a system like this, the good news in transition to ATSC 3.0 is you don't really have to do anything. The EAS insertion happens ahead of ATSC 3.0 encoding. So systems like this operate in NTSC, ATSC 1, ATSC 3. Quite simply, the audio is an interrupt of the main program audio stream. The text is sent to a character generator, media keyer, which is imposed in the video stream. And after the alert is finished displaying, it's removed from there. The banner ceases. The audio returns to normal programming. So pretty simple, elegant system in its simplicity, but a little bit dated. And again, the only good news about it, or some of the good news about it, besides the fact that it works robustly, is that if you have it, you don't have to spend any more to migrate it to ATSC 3.0. Let's see if this works. And this is in a quick screenshot what I'm talking about. A crawl on TV. Thank goodness the tones are not being played, but Canada has their set of tones, which sounds like a French siren. Doo-doo-doo-doo-doo. The US has the modem squawks. The Caribbean does not. The Caribbean has a screeching tone. Now the Caribbean has a screeching tone that's quite jarring, but it'll get your attention. We did another tone in Lithuania that's more like a bugle sound, which is kind of interesting. I meant to mention Anguilla. Anguilla is interesting, because they not only they're using CAP, they have 2 different CAP profiles. One CAP profile uses the U.S. weather codes. Why? They also broadcast over there those tones for maritime radios, for visiting ships, both commercial and individual. So that may be a consideration as well for Jamaica, whether on ATSC 3.0 or partnering with radio stations to make sure those alerts potentially could get to visiting ships. Hopefully this keeps going. Don't need that. Okay, ATSC3, and I'm going to get to the heart of the matter, and Neem's really going to drive at it. So ATSC3, as you've heard, as you know, is an IP-based system presenting much greater opportunities for information delivery. One of these approaches is advanced emergency information, which is a service, an IP-based service, to deliver a wide range of urgent information, not just EAS alerts. Urgent news from your newsroom about school closures, local incidents, vital community information that might come from the government, might come from your newsroom. Okay, we're getting this outside the government area. It could be your station directly entering information, your newsroom, third-party weather systems. It's an app-based service. So what we saw with EAS, it's burned into the video stream. With advanced emergency information, the message is delivered into your broadcaster application. Again, like I said, like a mobile phone app, as a bad analogy, but the message is delivered on the phone. The message has certain parameters that tells the phone into your receiver application. The receiver application gets instructions from the AA message on how it should behave. It's also opt-in. I said EAS is intrusive. Advanced emergency information doesn't need to be intrusive. It can be scaled to different levels of behavior. You may have a category, a priority 4 message, which is the highest priority, in which case maybe it does take over your entire screen. You may have a priority 1 message, which just a little icon pops up. And if the customer, used to be called audience, I guess in ATSC 3.0, we start calling them customers now. The viewer gets to select through and see if they want to see that message and how much more they want to see. So I'm going to get a little bit into the standard. Again, the core message in advanced emergency information is XML based. This XML message is transmitted in your low-level service in the ATSC 3.0 stream. That's important because it's robust, it's reliable. It's one of the first things that the receiver will encounter. Other resources attached to that XML message, like video or graphics. If we're picking Ananda alert, it could be you send the Ananda message as AAA text, and then the picture of the missing child or the suspect or circumstances are sent as NRT, non-real-time datacast information. The use cases here are helping expand on the government emergency information to the public. So the government may contact you about an Ananda alert. You, through your newsroom or other resources, may compile more information, local maps, where the person was last seen, and send that out to the public as an advanced emergency information message. It really extends, if you have a newsroom, it extends your newsroom capabilities immensely. If you don't have a newsroom, if you're a broadcast television operator without a newsroom, it also provides a very simple way of essentially mimicking a newsroom. We'll get through that a little bit later. So the advanced emergency information methodology includes multiple AEA messages in a table, AEAT. So think of it almost like an RSS or an Atom feed. One table can contain at least one or multiple AEA messages at the same time. Could be a lot of things at the same time. You may have a hurricane warning, a coastal flood warning. You may have an evacuation. You may be sending a notice about a mudslide. Different notifications going out to different groups at different times. These are I'll skip over going through all the parameters individually, but you can see the important ones here are who should get it, audience. I'm going to jump to a use case here. You could target an audience to everyone, general audience, in the viewing area. Everybody gets it within a certain defined area. You could send it to a parish, you could send it to a polygon, and everybody in that targeted area gets it. Or you could build a user group, a sub-audience, that could be resort communities. This establishment, for example. And that may be a business case right there where you're providing urgent information on behalf or in collaboration with the resort community. That may be a business model in and of itself where you're going beyond public messaging to forms of private messaging, supporting private messaging for residential groups. And that, by the way, is exactly what one of the cable operators is doing in the Bahamas. So not with AEA, but with a proprietary message format, but it's a real business case in the Caribbean. that that public alerts are being sent by the authorities. We're picking up the mobile alerts and putting them into the cable system, but the ability for the cable system to directly message televisions in the hotel rooms is something they're pursuing. I keep going here because I know I'm eating up time. So let me talk a little about the overall EA architecture. So we talked about EAS, the red box above. We can disregard that. Let's look at the yellow box in the diagram below, where you are getting sources of information, either internally or externally. Your government may well have, the Jamaican government may well have an official mobile alert feed or data feed that a system like this could pick up. You may have your own newsroom information. You may enter messages directly into the system. At that point, your AEA generator, is what we're generically calling it, the AE generator creates the XML AAT message. That XML message may well have resource links, either to non-real NRT data, that's datacast, or to web links, third-party web links that the receiver app will be instructed to pick up. Encoded over the air, I'll skip all this. Our friends at Treveni and Enesys would be much more elegant in describing what happens next, and NEEM, of course. But at the end of the day, what we're targeting are consumers with the application. And somebody said something really important that struck me. I know they meant it sardonically, but this is an important moment to have your design staff involved, not your engineers. Designing the presentation of emergency information is something that we've seen it built by engineering committees, or we've seen it built by design crews. You're going to want to get some creative design people involved in this. So I'm gonna switch this to NEEM now, if you come up. But the bottom line with advanced emergency information is that it is a very powerful, very flexible tool to not just do classic emergency alerting in terms of what governments want to do, but a very powerful tool for the broadcaster to extend its reach to its audience, to build firmer ties with its viewing audience for urgent information of all types, not just the classic disaster scenario, but urgent community bulletins. Again, school closing. Think about this in terms of what's critical locally, traffic information, beach closures, etc. So let me turn it to Neem, who can show us what we've been working with Sinclair.
Thank you, Ed. Hello. So before I start going to the slide, I would like to a minute to share with you my experience on my way here. So from the airport to here, I had a driver. His name is Craig. And Craig asked me, where do you want to go? Right? You in Jamaica, where do you want to go? So I asked him to take me to a gas station, a food place where I could find chicken, and somewhere I could have coconut on the street, like somewhere. But really, in the whole process, I really want to understand, how it looked like. So when we build a system that delivers emergency information, how do we get the message to the people who actually need them? So I went to the gas station, I walked around, I got coffee, a lot of banana chips. And I went to the food location, I got jerk chicken and bami. Oh my gosh, I want more of it. And then when we passed by a coconut stand, I'm like, stop. We have to, check it out. But what I didn't really tell him was, because I tried to understand, if we're going to build a system and deliver the message to people who need them, people at the station, people at the restaurant, the food court or food area, and people on the side, on the road. How does it look like? How do we get message to people who actually need them? And then it dawns on me, all the slides I'm going through right now, focusing mainly for folks like me who once lived on the mountain with access to TV. So with that aside, what I would like is to invite all of us to think about the 3 different scenarios. How do we actually get message to people who actually need them, may or may not have TV, through ATSC 3.0 capability? So here's the first slide that I put together. It's mainly for US audience. So from our perspective, we have, in addition to a long string, I don't know how many pages of contract requirement, which I haven't read. We have an expert, quite a team of experts reading them. But the most important for us is the social contract. In exchange for obtaining a valuable license to operate and broadcast station using public airwaves, each radio and television licensee is required by law to operate a station in the public interest. Public interest. So what does it mean? To us, it means emergency. Emergency is what we do. Saving lives, our way of saving lives in public interest is by evolving next-gen broadcasting capability to transmit and deliver timely and relevant emergency information to people who need them. So in my mind, the people at the gas station, the people in the restaurant eating food, and the people standing around having and getting coconut juice from a real coconut. All right, I'm gonna try to figure it out if I go to the right slide. All right, so these are an example, an implementation that we are doing in the US. So when we send out messages, especially from our newsroom, I will tie them all together, I promise you. It won't look that complicated. So from our producer tools, we enter the information using the information that Ed just went through earlier. And anytime you have questions, you know how to find me. And if you don't know how to find me, ask Madeline. She will tell you how to find me. So from our tool, we construct the messages and we publish the message. And here's a few examples of how the BA application will look. So first, we launch the broadcast application, and then when an alert coming in, how it would potentially look like. We have an alert with the BA running. When an alert coming in, the BA received information that actually delivered by the next-gen TV from the system up using lower level signal capability. I know I just got too technical right there. And the BA would render the title. It may also have the capability to read the message. So think of text-to-speech capability. Because not all the time that we have the ability to read everything. So we may have to rely on the audio part. And in addition, if a person wants to read more information to get access to the information, how does it look like? Am I in the impact zone? Where's the location? How does it look like? Potentially, if you have an ability to provide additional map information like evacuation map or the shelter, where to go to find them, these information that we send using ATSC 8331 AEAT syntax table, and to deliver all of that to the broadcast application and render it in a way that it can be consumed. So how do we target them? To start right now, we target by zooming in the location. So by knowing where the location, we also, in the signaling information, send additional information from over the air. And the broadcast application, if the user entered the zip code where it is, it can also help narrow down so people can actually decide what information they want to receive. So instead of receiving information in a very wide area, they can work with us and by narrowing it down even further. So it's a collaboration between the receiver and also by the broadcast application into the network. The other way that we also allowing the people receiving information is the ability to filter out. If you only want to get what you want, the important information that pertains to your everyday life, information that you need. For myself, I once lived on the mountain, grabbed my 2 cats, a box of documentation and little cash, and run, right? Those are the information that I'm likely would prefer to hear or receive. I may not want to receive everything, but depending on the person, we want to give that option to the person to decide how much information they want to receive. Next. So putting it all together, I promise. So this is unimplementation, Sinclair implementation. So our perspective, AEA system, or the routing capability is a core function. But at the same time, we have to build in such a way, not only it's IP redundant, but it's also redundant at the station level. This where are you? Hi, drove home. I got your message. I'm still working through enable in the lab. So in the event the IP network goes down, in the event the cloud go down, yes, they do go down. They usually go down when you don't want them to go down, like over Christmas or over Thanksgiving in the US, or at the moment you actually really need them. So when this happens, how do we do? So we have to build a system in such a way that it can recover by its own and still deliver the information over the air when we actually need to get that information to people who need them, people at the gas station, at the restaurant, or by the coconut stand. So tying all together the different fields and how does it look? Here is an example of the message, the emergency messaging using A331 protocol. So let me go back a little bit. One slide. All right. Is it the, Amy? Which button to use the laser? Oh, thank you. So this protocol is very, very important. This is the A331 that we use to deliver the NRT information. And also on our P network from newsroom to the system, we also use our own protocol to deliver. But internally, what Ed said earlier, the emergency alert information, the dash deck, not only it triggered the system, the audio and the text scroll, it also delivered the AAT information and then delivered and transmit over the air. What I didn't draw or complete the picture is the receiver, once it received that information through lower level signal LOS, it actually informed the BA, hey, there's an alert coming in, time to render it. So let me see. Ooh, wrong button. Thank you. Thank you, Ed.
Any questions before we break? Any questions? There's a question right now.
Yes. In the environment that we have to message, would it take into consideration of people who might have various disabilities, like visually impaired or have problems hearing?
Ed, would you like to? We did talk a lot about this, and Ed is much better at
Ed,
providing the description.
Yeah, because I
Ed,
got to.
would you be so kind as to kind of recap that question?
Okay. The question is, basically, what facilities would this type of system have for accessibility for people with hearing or visual or other challenges? I'm going to throw in multilingual, not that that's a challenge, I'll throw in multilingual as well. One of the things that was key in our minds when designing the specification, putting into the standard, and first time I actually had something I've written into a standard before. That's pretty exciting. But it was accessibility. Why? In the US and Canada, there are regulatory requirements. So anything you put on air must be accessible. And even though this is app-based, our assumption was it's going to have to be accessible. So the AAT is presented with text. The AAT is presented with audio, accessible audio. The AAT is also presented with the capability of being multiple languages. So that gets to 3 different modes of interactive action. When you get past that, I mean, do pillow shakers and other accessibility type of devices, that's a whole different discussion. For triggers for those, for special needs populations, we haven't gotten there yet. But the core message is presentation crosses language bounds. It's designed to be linguistic bounds and to be as accessible as possible through visual and oral media.
Any other questions? Did that satisfy the question? Any other questions? Anyone? All right, thank you guys very much. Appreciate it.
Thank you.
Okay, so we're going to break for 45 minutes. We'll be back in this room at 11:30 a.m. Give you guys a chance to check email, follow up with work, and so forth. So break, there's refreshments in the back, and we'll see you back here at 11:30.